Welcome back, guys. So, where did we leave? So yesterday we went through how we want to implement the interface for Virtio. So this is just going to interact with actual Virtio, and we need helpers for it. And our block layer is going to interact with this Virtio layer. So in general, the high-level overview is that we are currently still working on implementing the file system layer, and we have the VFS layer, and we have the block layer, and the Virtio layer. We need three different layers, all of them interacting to give us the single flow, which would be this, which is just if you just look up for a file, you get the file node, and all the internal things are handled by these three layers. And yesterday we went through a small understanding of what exactly the Virtio layer has to do. And in general, we have to prepare the request with a proper flag, and then we'll have to update the descriptor table with the requests and the actual data that needs to be put in and the status. And we also figured out that we need to be doing chaining for those descriptors and get the index of the first chain or the first node in the chain and put it inside the avail ring, and we'll have to finally notify the queue. So today let's just try to actually implement these things. And yeah, so nothing else to be done in our side, I guess, or at least nothing else to be researched. Currently, at least we have some high level overview. Notify the queue, so we need queue notify. Do we have it? Queue notify. We need this, and we have the avail ring, right? No, we don't have the avail ring. Let's just take all those things from here. This is the actual version documentation specification, actual specification for Virtio. So we need to get the descriptor table and avail ring and stuff like that. It should be, I believe it should be here, or did we make it different? Oh, this part is just okay, it's queue descriptor low high, and those are the actual, there's no such register here. I think this is that register, because I don't see any other register like that. And we have already noted down all other ones that we might need. We have the num max, num, we also have the select, we have notify, and we need three things, that is the descriptor table, avail ring, and used ring. And it asks us to set those values via these registers, but I don't see those registers here. Virtqueue is configured as follows here. Select the queue writing its index. First queue is 0 to queue cell. Again, check if the queue is not already in use. Read, okay, and then we just read value from this register. So let's just put this into our site too. Let's define read the maximum queue size from qmax, and then we pass the index to qmax and get the maximum. If the return value is 0, the queue is not available. Allocate and 0 the queue pages in contiguous virtual memory. Okay, aligning the used string to an optional boundary. Driver would choose a queue size smaller than. Okay, notify the device about the queue size by writing the size to queue num, and notify the device about the used alignment using writing its value in bytes in queue align. Okay, so the alignment should be written in queue align. Write the physical number of the first page of the queue to QFP, and I guess this is what is meant as this. I guess they would have already given the entire structure somewhere here if we just look through it. Let's see. Maybe we would get the entire thing somewhere here. We have the device ID, because if we read from this register we get the device ID, and every device ID has its own. Probably we are using something. We would be expecting something. as 2. Device configuration, I guess. If we want to entirely support this, which I probably will have to write almost everything within this specification, only then will be compliant of this specification, but that doesn't matter for us, so let's just go past some of this stuff and let's look for the general stuff that we actually need. I don't know if I'm gonna get it, but let's see. I think if we use these structures, one thing that would be good for us is that it would help us to directly map structure to this map address to this structure and just use the dereference the fields directly without having to manually offset things. See, probably we'll have to write something like this, because driver queues request to virtqueue, they are used by device. So we will definitely need this because we also want to write such requests, and maybe we can change these types. Let's just put uint32 here and uint. Hopefully it's the similar thing, not sure, but I hope so. uint8 is uint8. What? Incomplete type? Why is it incomplete? Maybe we need to give something here. It needs static value. I don't know. The specification did not say anything about it. So read is in and write is out. Discard, we also have write 0 requests and a flush request. Let's just double check if Lee32 means unsigned. Okay, it is unsigned. Maybe it's little Indian byte order. That's the difference. is the byte order of event 32. There's lots of minor details that we need to be sure of. Okay, let's see. We will have to understand this fully. Without that, there's no way we could finish this implementation. But I'm just looking for some initial things that I need. Specifically looking for these flags, if they have given these defined somewhere. This is the specification, so it should have something about it. Yeah, I guess there's a lot of stuff to implement around this, so let's just try to get a small example of writing to a file. First of all, walking, but even that, I believe it should take a lot of implementation. Okay, I'm just gonna search for it. Magic value. Magic. Somewhere in this magic, it's going to have the value. No, it doesn't. Shit. Maybe it's in the top. We went ahead of it. Because they even given lots of implementation examples. Yep, I guess it's somewhere here. We just went past that without even reading anything. So it's the beginning of the article that we should have read first of all. So structure specification, many driver and driver in memory structure layers are documented in C struct. All structures are assumed to be without additional padding. So yeah, we could just directly put them and dereference them. Common C complex attribute. So we just add attribute packed, so it will be fine. We need to get let's just add the definitions for these, or maybe you could find this somewhere, because we don't want to rewrite this whole thing. There must be some API that already has this C header file. It's Linux types. So we can just directly copy paste code from this specification. So let's just write defines for all these things, so we don't have to worry about them. Okay, almost everything is already in. There must be some other Linux inspection site. It's here probably. First of all, does standard int has any support for such I think standard int does not have anything. Yeah, standard int does not have that. print.h. We have to implement this. Oh fuck, we'll have to implement everything. I'm not in any mood to implement these three stuff. But I think if we implement this, we can just copy paste this fucking code. Yeah, big Indian is just big Indian and little Indian is completely fucked up. So we might have to write this part too. Okay. Oh no, I just don't want to write it. But if I write it, it would be so easy. Driver must update status setting bits to indicate the completed steps for driver initialization. Okay. Huh. Okay, so 32-bit, only 32-bit reading is atomic. If we want to read 64, we might have to call it twice, and we should not assume that maybe once after we got the 32 bits there might be a change happen somewhere, so we might have to check that too. So as long as before and after are not equal, we just keep doing that. Once it is equal, we can stop doing that. So mechanism for bulk data support on which is pretentious called virtqueue. Each device can have 0 or more virtqueues. Driver makes requests available to device by adding available buffer to queue, adding buffer describing request which queue, and optionally triggering a driver event. Adds a used buffer to queue. Lets the driver know by marking buffers. So each virtqueue can consist of 3 parts. The descriptor area is for describing buffers, driver area extra data supplied for device, and device area for device to rev. Separates the queue into several parts where each part is writable by either the device or driver or the device, but not the location within the parts. Each queue has 16-bit queue size parameter. Parts. Descriptor table. So this is what we figured out from this conversation, and it's already in the specification. So when a driver wants to send a buffer to the device, it fills a slot in descriptor table or chains several together. So that's the chaining part, and writes the descriptor index. So that is the within the table, whichever index we used, we just pass the index number to the ring, available ring. It then notifies the device. When the device has finished the buffer, it writes the descriptor index back to used ring, so we can know that that index has been done. But I mean, like, I understand that descriptor table is aligned. We can give the alignment and we can give the size. But where do we actually store this? So we have the actual register plus offset, where we can provide the descriptor table address. can we? Wait. We have the registers and none of the registers seem to take the descriptor. Maybe descriptor is static per queue. Each virtqueue can consist of 3 parts. So maybe we have to first of all register a virtqueue. I think so. I think we have to register a virtqueue, and that virtqueue structure is going to have the base addresses for these. And then we can properly put in the structure into those base addresses based on these specifications. Driver must ensure the physical address of the first byte of each virtqueue part is a multiple of a specified abort table. Okay, so we have to pass the entire virtqueue structure. So probably the virtqueue structure is going to have all these stuff. Okay, first of all, how do we pass? Okay, here it is. Okay, makes sense now. But it's legacy interface. Is it for? I think this is the virtqueue. So our let's just remove this. Okay, well, we also have to fill in this information. Okay, whatever. Let's start with the structure. This is the importance out of everything. So it's going to be a virtqueue, and it's going to take a struct which virtqueue descriptor. It's gonna have a queue size. Let's just put it as 512 now, and it's going to have a structure called virtqueue avail, and that's going to be avail and we have uint 8 pad of padding. Padding should be, let's say, 4 bytes aligned. Okay, let's keep it as 16 bytes aligned. And then we can put struct which, let's struct which queue used is going to be used. So like we figured, we have to write this starting address. We have to initialize this in our own virtual space, get the starting address of this. Okay, it should be multiple of the alignment value. Okay, then let's just put 4. Then we can keep everything 4 bytes aligned, or maybe 32 bytes aligned, or maybe 64 bytes aligned. Then if we use 64 bytes, we might waste a lot of space. Each queue has 16-bit queue side parameter. I get everything. I just still don't understand where we have to put this starting address, because let's say we finish assigning everything and we have the actual starting address. Where do we put that? Maybe we have to put it inside. No, we are actually notifying index through this status register, because we put in a index and then we notify. But then how come the Virtio will know that the descriptor table is in this particular address? Because it has to know where this particular thing is present. So each device is already having the device field and the virtqueue. So when in our case we have already read the register starting value and the device's status field is here, and we can all so probably device's virtual queue is also in some offset. Within that we are going to just put the entire virtqueue struct, or maybe we are writing the entire virtqueue structure into it. Yeah, because that which a single device can have multiple virtqueues, and it's possibly in some register, and we just and we know the structure of how that virtual queue will look like, which queue will look like. So now we just need the offsets, nothing much. We have the structures for everything. Supplying new available buffers to device, processing used buffers from the device. The simplest virtual network device has two edge queues, the transmit edge queue and receive edge queue. Driver needs ongoing packets. I need a block device, not a network device. But I guess the idea is the same. I think this is what I'm looking for. The virtqueue configuration. As a device can have 0 or more virtual queues for bulk data support. The driver needs to configure them as part of the device specific configuration. Driver typically does this as follows. For each virtqueue a device has write the virtqueue index to queue select. So initially we just start by saying select 0. So we write 0 to this. And then we read which queue size from which queue size. Do we have a size? I guess so. Oh, now I'm starting to get the hang of what's happening here. So we start by resetting the device. I think we have to write 0 into the status and then set acknowledge bit and then set ACK 1 bit and set driver status bits. Okay, I guess there's something called driver status bit. Okay, so and then read the device features and write the subset of features. Okay, here it just says perform device specific setup, including discovery of which queues for the device. Okay, I need to know this one step, that is as that this device specific configuration. What is that? So if I have the virtqueue struct ready, how do I pass that struct to the which, because I don't see any register offset accepting address to my virtqueue structs, or do I just, I don't know, I simply don't have the picture of what exactly they mean by we can provide the did not pass. But I don't see this register at all anywhere. We are back here. Yes, he has also taken the entire thing from the specification. Okay, so maybe he named it like this, or is that register really there? Wait. Okay, the registry is there, but we didn't see it in this. Oh, fuck me. It is here. Oh, fucking Christ. Last time when I checked, it was not here. Maybe there's two such. Is this in this? Oh, I fucking read the legacy version, that's why when I was checking here there was no fucking... Oh shit. Why the fuck did they put both the things in the same specification when they have a separate specification for the legacy one? Oh fuck me. So all I have to do is that put all those physical addresses into those registers properly. Nothing much. Oh, that's all you have. I have to technically do. So we prepare this register with the structure, and then we update everything into the respective registers. Nothing much. That is all we have to do. Okay. Fuck it. Let's add all of those. I think we might need everything. It should be device features, and it is 0x010, and device features just cell, it's 0x014, and we have device features, driver features. Do I need to actually I think I won't fucking use this driver features and driver selects. If I have to, I can come back. And nummax is 034, qnum is 038, and qnotify is 0x050. Do I have anything else? I have the status, I have select, I have nummax, and notify. I'll also add Control V. I select this and I go this. Fuck me. And I put put this, and I put this, and I type test. Yes, see. Yep. Holy fuck. Whatever I do. Yes, see. And then low. High. High and low. I think that's it. Descriptor high and descriptor low. Do I need these? I don't even need that. I need descriptor avail high, low, and descriptor avail high, and I need and used low and used low and used high. Okay, we have the queue descriptor low, user high, low and high, and used low and high. Now we just find the fucking offsets. Where is it? Queue descriptor. There's no fucking used here. Where is it? Device low and device high. Is it what calls as driver is avail and device is used? Because device is going to tell us back if the index is used or not, and driver, which is us, we have to read from the available. Shouldn't it be in the opposite side, because we read from device and we as the driver write to it? I don't know. Yeah, there's no driver low, driver high. There's only avail low, avail high, which is just this, which is driver low and driver high. Okay. So I have descriptor low, descriptor high. So I need avail low and avail high. So avail low would be 0x90 and avail high would be 0x94. And I think why the fuck am I even writing this entire thing? If I also prepare that structure and give this as the starting value, I should be able to fucking read all these with just this dereference. What do I do? Okay, we'll just stick with this. I think it should be good. Now we have the almost all the things that we need. Maybe we have to find the status code for this driver. That's not a good keyword to search for. Maybe you can put space in front of both things. Still there's 700 searches. Status. Status is only 150. Okay, we have the status here. It's status drivers 2. I think then we also have a structure for it. No flags for it. And is it not? Okay, it's not. I can write it. Acknowledge drivers 2 and failed driver. Okay, driver needs resets. What about normal reset? I did not mention that, but I guess that is 0. And we can take failed, which is 128, and we can take driver. Okay, which is 4, and we have features. Okay, which is 8, and device needs reset. Hopefully we don't have to deal with this case. Device needs reset, which is 64. Okay. We have the registers that we need to write to. We have some of the status codes that we need to push. Now we can actually get into the main logic. I guess there's this. So this is our logic that we need to write. So let's put it as init driver. Okay, void init virtio driver. Void here. I need this. And then what do I put? First of all, I need to write two helpers that can just simply read and write. I can copy that from we'll just write it void reads u32 right, because we have all the values separately, so yeah, let's read u32 and it is going to take un32 offset, and we have the base address. Where's the fucking base address? Okay, it's here. And this is just my header file, so let's just put things here. If we are reading, we should return u32. And if we are write u32, then we take a u32 value to t value, and we can write it. It should have these. Let's just put this here, and we have to set the Virtio base, and we have to status update. Status update is internally going to call these things. So let's just put void reset device, and maybe if we want to reset a device, we want the device ID. I think so. Or how else can we? What if there's multiple devices? Yeah, my implementation may not be that safe, because here I'm assuming this Virtio base. What if I just create a new Virtio struct that will have the base in it? source struct which IO base which IO, just which IO. I think it's not going to fucking conflict with anything. And it's going to have one value, which is which IO base. Do we need anything else? I don't think we need anything else, because if we have the which IO base, we can just do all the operations here. We can do some OOP and we can put some functions. You can just pause it. Anyway, it's the same fucking thing. So set which IO base is just going to take a which IO. So typing stuck is just so fucking annoying. Type def struct which IO. Which IO. Okay. Now I can just put it as which IO. Okay. And all my objects going to take this which IO. Or I can just define which IO object as self. I can just call self and dereference it. It would look like Python. Reset device is also going to take which IO object. Maybe initialize driver. Maybe that's not going to take a. Oh, every damn thing has to take which IO. Except for these two people. They are on separate category. These are separate. And let's also remove this and bring it here. And yeah. Now we have a little bit of room to do something. And okay, we also have this here. Let it stay here. Okay, we have a chair base, and then we have all these structures. Let's start with sysfy data. I have no fucking clue why the fuck it. Okay, maybe I haven't yet defined these things, that's why. I think I'll start implementing at least some of these. What's the time? Oh, fuck me. I need charge. is it not charging? I think now it works. Okay, now let me implement these. And it should be virtio blk.c. Okay, here let's just include virtio, and let's start with white resets. It's just resets. Okay, and to reset the device I have to send right into the reset offset that is 0, so I just say write u32 to which, okay, for that okay, so my write u32 also should take which offset it wants to write into. I think even my read and write should have the virtio. Fuck it, we'll try that approach. Let's be self alone. Why should I give it like this? Okay, it's not a fucking string. So it will take this entire thing. I don't know. I've never tried this before. I'm just too bored to write. Maybe I have to use typedef for that. No, I can't do that because this is just writing a bigger type into smaller one. So I have to use define. self, and yeah, the self is alone should be enough. We'll continue with this later. Let's just put right, wide right, yeah, wide right. But can I use self after that? That's not possible. I'm fucked. That's sad. Then maybe I can create another variable. Fuck, it's... Now I can just use Virtio object dot base. It's not a fucking pointer. So it's an is taking. I have to take a Virtio pointer, not the object. Now I can just dereference it and take Virtio base plus and offset and value. Plus offset dereference it and write it is no, it's just void pointer. How the fuck do we write to raw pointer? We maybe pass that as uint 8. Don't remember. I'll check how we do it for uart. Yeah, we just directly take the value and take that as, and we put it here. Okay. Maybe we can just copy paste this. So uint32 pointer and me difference it equal to value, and then we read it. I'm not setting volatile. I don't know. It's fine. Return star uint34 which IO objects, which IO base plus offsets, and we can make this static. Line 32. So this operations will be optimized. Maybe we might have to debug things first. Let's leave it as it is. We can think about optimizations later. So write u32 is which object, and offset is which IO flag reset. That's fucking which IO status. Within that I have to write value as which IO status reset. Okay, that is it. We know how to reset the device. Now we can write says bit as acknowledged. I guess it's the same fucking thing. I just copy paste it. ACK device. We just take status ACK. That's it. And what else? Driver status bits. So we also have to now check. I guess we can put all these three operations together. It's again looks redundant. Yeah, maybe we don't really. Maybe we can put the driver status bit directly in the init function. Void init. What is that? Init virtio driver. And first of all, we call reset device with virtio object, and then we call ACK device with virtio objects, and then we write the driver status as guess instead of status which I will star which I will object and we should take status UN64 status and just put status here and I think we don't need these two. I know these fucking shitty options and just put one update status. And update status which I object, let status as which IO status resets, and after reset we ck and then we say driver okay, and we set we are a driver, and then read the device features bit, write the subset of features listed by the field. We can read the features bit and then directly set let's see, do we have to read the features here? We'll think about that later. Let's just update features okay, features okay, and then reread status to ensure features okay bit is still set. Leave that. Perform. Do we have to reread the features bit here? Let's think about that later. And perform device specific setup, including which, okay, this is where we have to actually fill up our virtqueue. So we need to set up a okay, we need to allocate, and then we should be doing something like this. Virtqueue, which should be struct virtqueue q1 equal to, we'll have to use our kmalloc and put in size of kmalloc, size of virtqueue. What? Oh, size of, and we should have it virtqueue. There should be good. Maybe it will walk automatically. We'll think about that later. And then we can set the fields. Set the fields. IOS for the queue. And then finally we say driver okay. Great. Yep. I guess this is the general overview. But we need kmalloc. How do we import kmalloc? I think we can just import this here. And we should get kmalloc. Is kmalloc not here? Where the fuck is kmalloc? Kmalloc. Looks like kmalloc is somewhere else. So we can just put that here. I fucking. Let's just. Oh, piece of fucking shit. Okay, maybe we need this then. Was there now? Cannot value type. We are seeing to struct virtqueue. What's wrong now? Too few arguments the function call. Okay, we need allocate. Do we really need it? Wait, I don't remember how to use that fucking thing. Oh, we need the fucking global thing, but it is in here. Oh, shitting me. Let's just say init driver is also going to get the virtqueue. Struct virtqueue. And it's a pointer. And we don't need this anymore. We don't need the saver. We can Okay. Now we have okay, we are building things. At least it looks like that. Inside k-main, let's just include the what do I include? It includes, what is it? I fucking forgot the name. It's what am I fucking writing? It's Virtio blk.h. And it must be inside somewhere. It should be inside drivers. Virtio, okay. And then I can simply where the fuck is my code? Okay, it's here. I have the driver info, leave the driver info, and then I need structs which IO is equal to kmalloc size of Virtio and Virtio object. Where the fuck is that? 18. And Virtio base would be the result of 0. Driver info of 0. Yes, it is already event 34, so okay, it should be good. Okay, we have the global thing and we have virtio. We have the base. Now we can again allocate another object, which is a queue, which is of struct virtio queue, and it's of size struct virtqueue. Now we have the queue, both queues, and I can just call init virtio driver, and it needs a virtio object and virtio just queue. Okay, this should initialize the driver. Okay. And what else have we implemented? We still have a lot of work to do. We just have some high level helpers. Nothing much. It's already 2 hours. Okay. Okay, guys, then I'll try to continue this later today. Maybe next week. I'm not sure. We'll see. But then I guess today at least we have a small understanding of what exactly to write, because yesterday we got a high level overview of what to be do and what to be defined. Today we also have some algorithm and the exact locations to write and the exact registers that needs to be updated, and we have this big good specification that we can just go through and implement things one by one. Yeah, and that's it, I guess. Have a good time. Have a good week too. Bye.